Chapter 9. Working with Array and String. In previous chapter, we studied basic types supported in Java. Each variable of such basic data type can store only one value at a time. Such variables are called scalar variable. In this chapter, we will discuss some composite data types that can be used to store a collection of more than one data values. For example, array and string. Introduction to array. An array is a variable representing a collection of homogeneous type of elements. Arrays are useful to represent vector, matrix, and other multidimensional data. Vector is a one-dimensional, that is, 1D data structure that can be used to store list of items like characters, numbers. Matrix is used to represent two-dimensional, that is, 2D data structure like table of rows and columns. Arrays are useful when same operations are to be performed on various elements of the similar type. All the elements of an array are stored in memory using contiguous storage space. Each element is identified by an index position associated with array variable. In Java, array is an object used to manage list of items. Creating an array is a two-step process. 1. Declare an array object. 2. Create an array object. An array object can be created in two ways. 1. Using new operator and specifying the size. 2. Directly initializing the content of array. 1D array. Array with single dimension is known as 1D array. For example, vector, which can be seen as a collection of one or more scalar variables. Instead of declaring individual variables like marks1, marks2, marks3, marks4, marks5, we can declare array marks in square bracket 5 and accesses individual variable elements as marks in square bracket 0, marks in square bracket 1, marks in square bracket 2, marks in square bracket 3, marks in square bracket 4. To declare a 1D array, we use a pair of square brackets after array name or after data type. The syntax to declare array is as follows. Less than data type greater than. Less than array name greater than. Square bracket semicolon. Or less than data type greater than square bracket less than array name greater than semicolon. For example, to store the marks obtained by a student in 5 tests in mathematics subject, we can use an array of 5 integer elements. Array object named marks with size for 5 elements can be created as follows. int marks square bracket colon slash slash declare array object marks is equal to new int in square bracket 5 colon slash slash create array object. We can combine above two steps and create array using a single statement also as follows. int marks square bracket is equal to new int in square bracket 5 semicolon or int square bracket marks is equal to new int in square bracket 5 semicolon. Here name of the array is marks. It refers to memory location where 5 integer values are stored. Integer of int data type uses 4 bytes storage space. Thus array marks requires 5 into 4 is equal to 20 bytes in contiguous locations in memory. To refer an element of an array, we use index or subscript in square bracket after array variable name as shown in figure. Index specifies the position of an element in an array. For example, marks in square bracket 2. Index value starts from 0. In figure, the array variable marks has an index value from 0 to 4. Here, marks in square bracket 0 refers to the first element and marks in square bracket 4 refers to the last element. As explained in previous chapter, An object is a reference variable. Array being an object in Java. Array name is also a reference variable. It contains reference to memory location where the array elements are stored. See figure. As array is an object, so its elements are initialized with default values. Figure shows an example of how to use an array in Java programs. One can also specify the initial values of data elements while declaring an array. 1D array is initialized using comma separated values of data elements in braces. For example, int marks square bracket is equal to in curly bracket 90, 70, 77 curly bracket over semicolon, or int square bracket marks is equal to in curly bracket 90, 70, 77 curly bracket over semicolon. Note that when an array is initialized, it does not need the use of new operator. Its size is same as the number of values specified in braces. The code shown in figure uses different ways to create and initialize array. Note the use of class method display bracket used to display contents of an array. Class methods are declared as static and can be referred without any object in the class. In Java, we cannot specify both the size of dimensions and initial values of the array elements simultaneously while declaring an array. Figure shows the code to illustrate the statement. If we declare an array variable without initialization, only a variable is created to hold the reference as shown in figure. It does not create an array object. That is, no memory is allocated for array elements. If we try to access the elements of an array, it will result in an error. Every element of an array is an individual variable that can be referred by using index. Like variables, to change the value of an element, we can use assignment statement referring a variable element on left side. For example, marks in square bracket 3 is equal to 56. Let us write a program that computes an average of 10 floating point numbers and execute it. Observe the code listing and its output as given in figure. Here we need to use the same operation, add number to sum, repeatedly for different elements of same time. Use of an array helps in declaring 10 variables at a time and using a loop to perform same operation on different variable elements of an array. We can perform various other operations on array. For example, compare two arrays, copy all the elements of one array to another, search for a specified element in array, sort elements of array, and so on. For all such operations, we may write procedures as we did for finding average of elements. Instead of writing such code ourselves, we can use various static methods provided by Java using java.util.arrays class. In Java, array is treated as an object of this arrays class. This enables us to make use of methods of arrays class with array type of data. The code listing and its output in figure shows how to use method sort bracket and fill bracket of java.util.arrays class. We can use sort bracket method to sort entire or part of array. When we use only array as an argument, it sorts an entire array. When we invoke this method with three arguments, array, start, last, it sorts partial array from element at index start to element at index, that is, last one. For example, the method call java.util.arrays.sort in bracket list, 1, 5 sorts elements of array list from list in square bracket 1 to list in square bracket 5 minus 1, see figure. Method fill is used to fill the whole or partial array with specified value. When the method is invoked with two arguments, array and value, It assigns the specified value to all array elements when it is invoked with 4 arguments: array, start, last, value. It fills partial array from element at start to, that is last one, with specified value. For example, fill in bracket list, comma 7 assigns value 7 to all elements of list array, whereas fill in bracket list, comma 2, comma 6, comma 5 assigns value 5 to elements list in square bracket 2 to list in square bracket 6 minus 1. See figure. To search an element in an array, arrays class provides binary search bracket method. We will write our own method to search an element in array using linear search. Linear search method does element by element comparison in a serial fashion. Refer code listing and its output given in figure. It returns index position when an element is found, otherwise it returns -1. 2D array. Two-dimensional, that is 2D arrays are used to store tabular data in the form of rows and columns. For example, to store 5 students' marks in 3 tests, we may use a tabular arrangement of marks in 5 rows and 3 columns as given in figure. In mathematics, we call it as a matrix of 5 rows and 3 columns, where each element contains marks. In Java, 2D array can be declared using an array name and 2 pairs of square brackets to specify the size of 2 dimensions row and column respectively. For example, following statement declares and creates an array named marks to store 5 into 3 is equal to 15 integer values in contiguous memory locations. int marks square bracket is equal to new int in square bracket 5 square bracket over in square bracket 3 square bracket over semicolon. Here, the logical view of array elements is a table of 5 rows and 3 columns. Physically, they are stored in memory using contiguous memory locations for 15 integers, that is 60 bytes. Java does not support multidimensional arrays directly. To create 2D array, we have to create an array of array. There is no limit on number of dimensions. In marks, in square bracket 5 square bracket over in square bracket 3 square bracket over, it creates 1D array object 5 elements and each element is 1D array object of 3 integers as shown in figure. Declaration and initialization of 2D array is very similar to 1D array except the number of dimensions. In 2D array, each row is considered as 1D array element. Thus, like 1D array initialization, each row is initialized by enclosing its elements in a pair of braces separated by comma. To initialize 2D array, all these initialized rows are to be enclosed in curly braces, separating them by comma. Like 1D array, 2D arrays can be declared in various ways as seen in code listing given in figure. Figure shows output of the code. In Java, 2D array is considered as an array of 1D array. So rows of 2D array can have variable number of columns. Figure shows how to use 2D array of characters to store 5 names of computer programming languages. Each name is stored in different row and all names have different number of characters. Thus, each row is of different size. Size of each row can be known using length property of 1D array. Figure shows how to use 2D array with varying column size. Here, we have used length property to get the number of elements in 1D array. For 2D array, it returns number of rows. For 1D array, it returns number of columns in specified row element. Remember that for 2D array, number of elements is considered as number of rows and each row is 1D array. In short, length property used with only array name returns the size of its first dimension. Later we will see that 1D array of characters can be defined using string class available in Java. In figure, we have used 2D array of bytes to store names. Here, it shows that initial char type data values are converted to byte data type and the characters of names are assigned their corresponding ASCII values. Points to be remembered. Array is a collection of homogeneous type of data. Array elements can be accessed using index for each dimension in square bracket. Index value starts with 0. Multidimensional arrays can have variable size of second, third dimensions. Attribute length is used to determine the size of the dimension. Array is treated as an object. Declaring an array without initialization does not create an array object. Strings. Strings is nothing but a sequence of characters. So, 1D array of characters can be considered as a string. We have already studied and used strings literals where a sequence of characters is enclosed between double quotes. To use variables that can store strings, Java supports two types of strings that are handled by two classes, namely string and string buffer. In this chapter, we will see the first one. Some of the constructors that can be used to create an object are as follows. String, bracket, without arguments create a string object with no character. String, in bracket, char, array, in square bracket, bracket, over, creates a string object with its initial value using array argument. String, in bracket, char, array, square bracket, comma, int start, comma, int len, bracket over, creates a string object using 1D array argument starting at array in square bracket start with len number of characters. String, in bracket, string strobj creates a string object which is same as object specified in argument. String, in bracket, string literal creates a string object that refers to the literal specified in argument. Figure shows the use of various types of string class constructors. Do not forget to use new operator while creating object. In Java, characters are stored using 2 bytes. To save space, if the characters are ASCII, we should use an array of bytes instead of array of characters. We can use a constructor with array of bytes as an argument. Try the same program by replacing char array with byte array. Note: literals are stored in memory. When two string objects are created using same string literals, memory space is not allocated for second object. Both objects refer to same memory location. Separate memory is allocated when string objects are created using new operator even if strings are identical. Code listing given in figure shows such an example. In code listing given in figure, note that in double inverted comma, str1 is equal to str2 double inverted comma. Compare the contents of str1 and str2 and not the objects at str1 and str2. String objects str1 and str2 are created using same string literal but without using new operator. Here, both reference variable str1 and str2 refer to the same instance as created for str1. For object str2, separate memory is not allocated as seen in figure. In the same program, string objects str3 and str4 are created using new operator. The contents of both these objects are same and they refer to different memory locations. Separate memory is allocated for these two objects as seen in figure. String class methods. The string class provides methods to compare strings, find length of string, combining strings, obtaining substrings, converting strings, splitting strings, searching for character or pattern in string, etc. We will see the examples of using some of these methods through programs. The program in figure shows different ways to compare strings or part of strings. The syntax and description of various comparison methods is shown in table. Method. Boolean equals in bracket string str. Description: return true if invoking string is same as str. Method: Boolean equals ignore case in bracket string str. Return true if invoking string is same as str after ignoring case, that is case insensitive. Method: int compare to in bracket string str. Description: returns 0, less than 0, greater than 0, integer if invoking string is equal to, greater than or less than str respectively. Method: int compare to ignore case, that is string str in bracket string str. Description: same as compared to but case insensitive. String class provides methods for other tasks as follows. Some of them are given in table. Extracting part of string, replacing characters or substrings, splitting string into substrings, getting number of characters, getting character at specified index position, converting string into an array of bytes, converting string into lowercase or uppercase, appending string, copy string or part of string. Method: int length bracket description returns number of characters in invoking string. Method: char index 80 in bracket int index. Description: returns character at index position from the invoking string, index considered from 0. Method: byte square bracket get bytes bracket. Description: returns an array of characters as bytes from invoking string. Method: void get chars in bracket int from index, int to index, char target square bracket, int target index. Description: copies characters of invoking string from index to index. 1. To target array from target index onwards. Method: string concat in bracket string str. Description: returns a string after appending str with the invoking string. Method: string to lowercase bracket. Description: returns a string with all characters of invoking string converted to lowercase. Method: string to uppercase bracket. Description: returns a string with all characters of invoking string converted to uppercase. The code listing given in figure shows how to use some of these methods. Note: with array variable, length is an attribute or property of array, whereas with string object, length is a method. So we need to use bracket while using length method with string object. String class of Java does not provide any method to reverse a string. So let us write a program to reverse string. Refer code listing and its output given in figure. Here we have written a user-defined method reverse str that reverses the string as follows. 1. Determine the length of string using length bracket method of string class. 2. Convert a string into an array of bytes using method getBytes bracket of string class. 3. Exchange half of the elements on left, that is, starting from first towards right, with half of the elements on right, that is, starting from last towards left, of a byte array. 4. Construct a string object from a byte array using constructor and return it. Date class. We have studied about string class and arrays class provided by Java. Java library also provides date class in java.util package. Date class encapsulates both date and time and represents the value using milliseconds precision. Figure shows the use of date class with code listing and its output. Table lists Some of the methods of date class. Method date bracket description constructs date object using current system time. Method date in bracket long elapsed time description constructs date object using specified time in milliseconds elapsed since January 1, 1970 GMT. Method string to string bracket description returns a string representing date and time of invoking object. Method long get time bracket description returns number of milliseconds since January 1, 1970 GMT. Method void set time bracket long elapsed time description sets new date and time of an object using elapsed time. Calendar class. Like date class, calendar class is also provided in java.util package. This class can be used to extract detailed calendar information like year, month, date, hour, minute, and second. Here we will see the use of Gregorian calendar, subclass of calendar class. Figure shows an example program to use calendar class along with its output. Note the use of user-defined class method display bracket used to display various components of date and time. Like get methods, we can use set methods to set the value of the field constants of calendar class. For example, if calendar is an object of class calendar, then execution of call inverted comma calendar dot set in bracket calendar dot date comma 20 bracket over inverted comma will set the date to 20. Table lists the integer constants defined in calendar class. These constants are given meaningful and self-explanatory names. Constant year description year of calendar. Constant month description month of calendar, that is 0 for January, 11 for December. Constant date description day of calendar month. Constant day underscore of underscore month description same as date. Constant hour description hour in 12-hour notation. Constant hour underscore of underscore day description hour in 24-hour notation. Constant minute description minute. Constant second description second. Constant am underscore pm description 0 for am, 1 for pm. Constant day underscore of underscore week description day number within a week, that is 1 for Sunday, 7 for Saturday. Constant week underscore of underscore month description week number within the month. Constant week underscore of underscore year description week number within the year. Constant day underscore of underscore year description day number in the year, that is 1 for the first day.